Now we have our second presenter, and his name is Mr. Aman Parnami. His talk is on weaving interactivity into everyday objects and experiences. Introducing Aman, Aman is an assistant professor and the head of the Department of Human-Centered Design in Indraprasth Institute of Technology, in Indraprasth Institute of Information Technology, Delhi, sorry. He holds a doctorate in HCI and a minor in ID from the Georgia Institute of Technology. At IIIT Delhi, he directs a leading HCI research group called Weave, where research at the intersection of electronics, computing, design, and media is conducted on exploratory and need-based projects. He's also a co-founder for a sports analytics spin-off from his group called Tweek. He's a proud journalist in academic and fitness interests. So over to Aman now. Aman, you can share your screen.
Uh, I tried sharing my screen. Divya, is it visible to people?
Uh,
Let
I can't see it yet.
No, man,
Let me try again. Okay, let me try again.
Yeah.
Okay.
Yeah.
And now is my slides visible?
Yes.
Okay. And is it visible now? The
Yes.
title of the
Yes.
Okay, good. So I can start.
Yes.
So first of all, I would like to thank everyone for getting together on a Saturday, on an evening. It's a wonderful evening out here in New Delhi, which is not usual. I thank the organizers for the opportunity to share my views on HCI and my journey in HCI as a researcher. And very happy to be able to speak about this and also possibly get feedback from the audience. Okay, I'm following up after Amit, who gave a wonderful talk about the organizations and relevance of AI in terms of change of organizational culture and using nudges. My talk is going to be on a slightly different take and a different way of approaching this. First of all, coming from academic research background, and secondly, the idea of kind of sharing my journey as kind of one data point for how some of you who may be budding researchers may think about HCI research in academia, and maybe suggest some pathway for you to get into HCI if you're still on the boundary. Okay, so I'm Aman Parnami. I'm an assistant professor at IIIT Delhi. All the views in this talk are my personal views, do not represent IIIT's stand on anything. So the title is Weaving Interactivity into Everyday Objects and Experiences. That's my research kind of mission as well. I'll get started right away. The talk is going to be structured in this way. I'll first talk about myself, like an HCI researcher. First, gotta put my prejudices or my biases up front so that you know what I'm talking about and why I'm talking about it. Then I'll talk about my understanding of HCI research and where I come from, and then weave as in the research that we do in the research group. I'll also share a little bit about the teaching practices that we have, and then I'll come back to a few takeaways, some broad takeaways that I would have for possibly the students in the audience, not necessarily for the other academicians as well as industry partners. Okay, so starting with about myself, to me here, what I've structured is kind of some things that influenced me in my thinking, and going back to the childhood, right? So talking about, first of all, the idea of physicality and play. So I grew up not necessarily on playing computer games, but playing a lot outside with marbles and kites, and being on bicycle and being jumping around and running around and all those, right? So that has become part of my life into how I approach HCI as well and the kind of work that I do. I love to do things myself. Even I'm very proud to say that I cut my hair for past 8 years now. I've become pretty good at it. I think so. So far, there has not been a very, very big failure. as far as I remember. So I just take pride in doing that, and I think that reflects on my way of approaching research in HCI and the kind of research within HCI that I align myself with as well. I very much cherish the freedom to choose my path, and this goes long back to actually rooted in the education system and a lot of experiences that I've had along the way. Proud to say that I'm an IT Bombay alumni. I did take a class with Anirudh Joshi. He may not remember. This was in my last year as an elective in HCI. I was a dual degree computer science student there. At that time, it didn't seem like HCI is going to be my path forward. Um, uh, but right now it is. I took a longer journey towards that, worked for a couple of years, realized that HCI is something that is growing up on me, went for further education at Georgia Tech, and then now I'm a faculty here, practicing as well as mentoring other researchers, budding researchers. So I very much cherish this freedom to choose my path, and I think education system a lot of ways constrains that, and so I'm trying to work against some of those things by being in an academic institute. Um, the other is this kind of more of a personal, and because this does reflect on kind of the path of an academician and how do you want to decide to be an academician. Just enough money to kind of survive and to be able to do what you want to do is kind of what drives us more. And for me personally, being close to nature and family is important. Finally, and most importantly, I think to HCI and my role as an academician is that I wish to make a difference through mentoring. And this is something that I've been doing back since 2003 when I had the opportunity to share something that I had done. And this was in my case, the most important thing at the time was clearing JE to get into IIT. That was a tough path, and I started mentoring folks and started sharing my experience with people, and that's when this kind of idea of being able to help others out who may not be as privileged, who may not have had the chance or experience that I have, sharing that back. And this till this day, I continue to do that.
Divya, I'm not able to hear Aman. Is it
Yeah, I think,
challenge at my end, or
yeah, I
we
think
all are
there's the
facing?
problem.
Okay.
Hello? Hello? Uh, Hello, Aman, are you here? I think there's a...
Yeah, there seems to be some issue. Maybe he will log in again.
Mhm. Hello?
Can you see my screen?
Yeah, Aman, I think we lost you, unfortunately. So,
Now, can you see my screen?
yeah, we can.
Okay. Uh, did you lose me at the beginning of this slide?
Uh, the slide before this?
Okay. Here?
Yeah, like I think we were on the last point of this.
Okay, so the last point was that making a difference through mentoring, this is important to me, and this is what I do as an academician, and this is the most important piece of what I do in work. So I wanted to set the ground context for what I understand as HCI. I'll not go over the definition again. This is from ACM, and I think I'll be preaching to the choir if I speak about this more. But I do want to say that I come from a more of an interdisciplinary background in HCI, where from Georgia Tech, where computer science, design, and and psychology were kind of the pillars from which HCI kind of originated. And then there are further subfields that have an influence. In my particular case, social sciences, mechanical engineering, electrical engineering, and then many more, right? But essentially, it comes down to understanding human behaviors and building interactive technology. And I tend to focus more on the building part, as I've already stated, very much interested in making and doing things with my own hand, right? So that to put that further in context, I would like to leverage this kind of a set of contributions that are identified by the Chi community, and specifically the researcher Jacob Obrock from University of Washington. He lists down these 7 types of HCI research contributions, out of which I'll not go into detail of all of them. I think some of them are self-explanatory, out of which the 2 that I primarily focus on in my group is the empirical research, which is you have a question, a research question, and you try to pursue to answer that through studies or through discovery. And then artifact contribution is most technical HCI research contribution. So think about cool demos, think about cool gadgets, playing with that, doing new research with that. That's kind of the artifact, or creating your own systems. That's what the artifact contribution is, right? So the group primarily focuses on empirical research and artifact, so far not the other ones. So then the group that I work within, which is Weave, which I created 2 years ago, roughly. This is the founding team of students. Most of them undergraduates. A few.
Sorry to.
Yeah.
There's a slight lag in the slides. So now we are seeing the artifact slide.
Oh.
Yeah. So I don't know.
Do you want me to try and?
Yeah. Now we just briefly saw your students and then it went off. Yeah.
Okay. So let me try to go to the next slide and then come back just to see how quickly it is refreshing.
Yeah, still on the student side slide.
Is there an arrow sliding
arrow,
in?
we saw the arrow now, yeah.
Okay, so I'll try to go slowly so that it loads in properly by the time I'm speaking about it, but you can focus on me speaking, not necessarily something on the slides, because I think I'll try to explain everything as much as possible, okay? So, this is the founding team. I'm at the center, hanging from the top, having a lot of fun with the group of students. Okay, what we do at Weave, and the title of the slide is very much influenced by this particular man, Mark Weiser, whose work I had studied quite often during my PhD work. He wrote a seminal article called Computer for the 21st Century. He was a researcher at Xerox PARC in Palo Alto. So this kind of thought from his side in the paper was the most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they are indistinguishable from it. So I kind of borrowed this word weave and this idea of weaving the interactivity that we create through artifacts into the everyday objects and experiences, right? That's kind of how I designed the vision and the mission for the group that I work in. Okay. Here is a quick overview of the kind of research, as I mentioned in my intro, is that I'm going to go over a few projects. This is kind of setting the context. I'll not use this framework slide much more, but just kind of set the context that we do both discovering and meeting needs as well as technology exploration. We work in a lot of different domains like health and well-being, sports, education, technology, storytelling, and most. Contributions we make is sensor development, system development, toolkits, and frameworks and design spaces, and in a few cases, startups as well as patent ideas. And the bottom figure is kind of setting up the stage framework for how we think about the integration between the physical and the digital world, because the interaction, most of the things that we do are at the boundary there, and dabble in both because of the nature of our work, that we build stuff as well as we provide interactions through it. So in the digital side, we build AR and VR experiences, we build apps, we create AI assistants. On the physical side, the physical form factors that we typically deal with is wearables that are put on the body, tangibles that are things things that you can hold in your hand and experience, and ambient things that you kind of place in the environment around you, right? So this kind of just a very, very broad view. Before I get into a few concrete examples of the research that we have published recently in the past couple of years, and specifically talk through a few of those examples. Okay. So now I'm moving on to the first project, Menstruloss. Just a quick check. Divya or Anirudh, are we on Menstruloss slide now?
Yes, yes, you're on that slide.
Okay, good. So Menstruloss, Menstruloss is a project that a PhD student of mine is working on, Manideepa, and the idea here is that we are trying to quantify the amount of blood that is lost during menstruation. And some people may know that as periods. The technical term is menstruation, and the goal here was that after talking to a couple of gynecologists and understanding the problem space about the main things, main parameters that they would ask information about if they are dealing with an issue related to menstruation, are one of them, primary one, is blood loss. And typically how they do it is it's a very kind of qualitative way of asking about how many pads did you use, or how frequently did it occur, and was it heavy flow or was it low flow. So as you can see, all the terms that I used so far were quite kind of subjective and left to the assessment of the person who has come as a patient, versus being able to specifically tell that, okay, this is how much the flow was, this was much more than my previous few cycles, and I see a problem here, right? So that was the kind of the discovery part of our understanding of the problem space. And so we designed a sensor, in this case, the instrumentation of a sanitary napkin and a new form of sanitary napkin, which does not change the behavior of you wearing the sanitary napkin or using it, but it does provide you extra information with a little bit of overhead, definitely, about how much the blood loss is. And potentially, and the goal forward is to make it as into a pre-diagnostic tool of many things that could be pre-diagnosed with just kind of monitoring the menstrual pattern and the cycle. Okay, so that's one work where sensor development. The second work, and feel free to stop me at any point, or you can ask questions later. So the second project is choice blindness. This is a very interesting, very quick exploration that we did. And here the idea was that we took the standard example of a psychology experiment, which is about choice blindness, as to how you're blind towards your choices that are happening in a quick moment. And so what we did here is, as you can see in the pictures, is that we have a setup in which there are two elevator doors, and the bell is ringing to suggest an urgency that you have to get into one of those doors. And what you do is, you're wearing a headset, you are in virtual reality, you're wearing a headset, you quickly choose which doors you're going to enter. Both of them are equally probable. You just enter one of them, and as you are at the threshold, what we do is we swap the scene. We swap the characters in the two elevators, and you enter and you stay there for a couple of seconds. We stop the session, and then we ask you, why did you choose the door? Because both of them were open for you. Why did you choose this particular one versus the other one? And you would be surprised to learn that people, though they had chosen a different set set of people in the elevator, but then the one that they ended up in, they start justifying the one that they ended up in, and do not even recollect that they had chosen a different one. And so in this case, what we did, and this actually kind of brings out their biases that are implicit, which you do not necessarily talk about or maybe are aware of. So in this particular case, we had one particular side where we have people with darker tones of skin, and one particular side where we had people with lighter tones of skin. And so the bias here was kind of more of a color and a race bias that we were trying to exploit. And we clearly saw that the people who tend to move towards people with lighter tones and were replaced with people with darker tones still try to justify that that's the reason I chose the people with darker tones, because, oh, somebody's wearing a very nice shirt, or somebody has a really nice haircut or something like that. And to them, it was a complete surprise when we told them, in fact, you chose a different one. We just replaced it and you didn't notice. So this is kind of a very tip of the iceberg, kind of an experiment to show what you can do with virtual reality and such systems where you can fully simulate a kind of a new environments. Okay. Now, changing tracks towards more of the kind of the building and the development side, this project, Virtual Bricks, the idea here was that, again, in virtual reality, typically they come with controllers that one can use for specific experiences. But when you want to try to build your own experience, you do not necessarily have a controller that matches the kind of experience you want to drive. For example, I want to have a car driving experience. My controllers are more like sticks, so I cannot have kind of a driving wheel kind of experience, right? So looking at that particular issue, and then being influenced by Legos as kind of allowing you as building blocks to build any kind of structure, we merged the two together to say that what if I could use Lego-like blocks and I could create any controller for you of any shape, size, and experience that you can then use to drive your own virtual reality experiences that you developed. So we did exactly what I said. We used Legos for structure, and then we built a couple of specific Lego blocks with electronics embedded into them. That was the part which was allowing us to then kind of hack into the virtual reality system and then be able to drive our own experiences. So this was a really nice exploration in that direction. And similarly, another area that we explored is again picking kind of an existing structural element like balloons that you may have lying around, or you can buy cheaply, and then thinking about this area of soft robotics, of being able to create kind of these animated or controllable robots using balloons rather than having to kind of fabricate them from scratch, everything like using silicone and building these pneumatic structures. So here we showed very quickly with a few components how you could take balloons and attach these components to them, and then you can drive kind of robotic behavior using balloons, and that saves you time and saves you money, right? So this is another such exploration where the physicality was important, and a particular problem that we identified, and we tried to make a quick kind of system for that. This is an example of a design space, kind of a paper. So Gehna, as the Hindi word suggests for jewelry, is about interactions with jewelry. Now there have been, I'm sure all of you are aware that there is a lot of interest in rings, interactions with rings, interactions with bracelets, interactions with perhaps ear mounted devices or even glasses. We wanted to look at jewelry as a whole, and specifically in the Indian context, the variety of jewelry and the intricacy of jewelry was of interest to us. So what we did was we kind of compiled a list of jewelry items that we could find in the local market in Delhi. And we created a kind of a structure around it to say that, okay, these are the structural elements of jewelry, and those structural elements are primitive to any jewelry that you could pick up, of course, with further ornamentation that is possible. And then using the understanding of the structural element, we kind of created and brainstormed these new types of interactions with computing devices that could be facilitated because of the structure and the affordance of these jewelry elements. And here is a kind of just one of the images from the paper that shows you interaction with different jewelry elements. And we have much more. So this was published at CHI 2019. Feel free to look at it. In the space of educational technology, we have again taken this approach of constructionist learning, of being able to learn by doing, which is very much practiced in the design field. And what we did was we kind of took this tangible elements which could be placed in the ambient environment or on the body as a wearable, and with some form of markers around them, and then an augmented reality lens as a phone application that one could use to connect the tangibles together. And some of the tangibles represent input elements like buttons and sensors, and some of the elements represent output elements like fan, vibration, sound, light, and such. So the idea was to teach kids in the middle school about this idea of electronics and this playful way of knowing what are inputs, what are outputs, what are sensors, what are actuators, and also a little bit about use of augmented reality to be able to connect them together. And so this work was published at is Ingot in 2019. And here we did several user studies with the participants in the schools nearby and saw a lot of creativity come out in terms of an understanding of what are inputs, what are outputs, what are sensors, and what are actuators, right? So again, an interesting exploration based on the physicality of what we built. Changing track towards storytelling, which is a common theme that we are focusing on quite a lot these days in our group. This is one of our first exploration called Aesop. Aesop is a storyteller, and this idea is that we wanted to take this experience of 4D movies where you could have your chair vibrate, you could have water sprinkled on you, you could have fan and air and all those things. To bring that to a normal storytelling, either that happens in library or in a reading room, or it happens at home with a parent and a child sitting together, right? So that was kind of the motivation. We wanted to make this a low barrier thing for people to be able to create multimedia storytelling experiences. So you take a normal story, like you could pick Panchtantra story, or you could pick Betal Pachisi, and you could take one of those stories and you could try to create a multimedia experience around it. And what we did was we made a desktop tool where you would have the story either downloaded or entered by you, and then you would be able to have kind of program that using a block-based programming approach like Scratch, if some of you may know about it, or MIT App Inventor is another way, where you kind of pull in blocks on a canvas, and then you connect the pieces together, and then you tweak those to more like write a program. So we programmed these experiences in form of cues and visualizations. So cues were like the spoken keywords. Like when you're reading the story, you may mark a few keywords to say that, okay, this is the word at which I want to trigger something. You may also have facial expression because you have a camera. You may have hand gestures, and you may also be playing music in the background. For example, tuck, tuck, tuck on the table, or making sounds or whistles and other. And the output could be at that point, to make it more engaging, could be specific sounds that you've connected them with, or lights in the environment like smart home, smart lighting. You could have animations on the screen, or you could even have robots connected to it like Lego Mindstorm kits, and those could do specific behaviors as a result of you speaking. So this was kind of a first exploration about making storytelling more engaging for the audience. Now, the research that we have done so far has been about, different areas that I've talked about in terms of storytelling, in terms of specific societal need, and educational technology. This is one of those examples where we were working on a problem related to motion capture for the virtual reality project, the first one, Virtual Bricks. And from there, it came out an idea for motion capture at a low cost, and specifically for supporting sports performance analysis and improvement. So Tweek is a company that we have started from the group. I'm a co-founder of the company with two of my students, and as you can see in the picture, we are making motion capture suits, and we have analytics software to go along with that. We'll love to share more about that, but in the interest of time, I'll move on. And to wrap up the research part and the output from the lab, this is a couple of wearable patent applications that have come out from our work and exploration. On the left-hand side, this is for a traffic policeman. We have built a specific set of sleeves that can help with them. Yes?
Sorry, the slide is still not loaded. You can just go ahead and come back. Now it's okay.
Okay, good. Thank you so much. So on the left-hand side is a sleeve for traffic policemen. The idea was that we identified that in foggy nights in New Delhi, they are not visible, and also the signs that they produce with their hands are not up to kind of the training that is provided, and is not very clear, ambiguous. So we wanted to improve that by making sleeves, and then the gestures being detected and the patterns being lit up so that visibility is maintained for their own safety, as well as ambiguity is resolved for the people who are looking at those signs and the traffic moving along according to that. The second one in the center is for a bus conductor. So we did a study on the bus conductors in the DTTC buses, where we understood kind of their flow of interacting with the two pieces that they had to manage the money as well as the tickets. One was an electronic device and POS device, and one was kind of a bag to manage the money. We integrated the two together in a simple flow, so that you just kind of, your hand flows from the top left to the bottom, and you are able to you are able to key in as many tickets as are needed, which are through the buttons on the left, on the top, and also take the tickets and hand it over to somebody. So it was reducing time, as well as them not having to carry two things in their hands, was something that we improved upon. And then on the right hand side, we have a specific wearable that we built for the security guards within our campus. So what we observed that during the night shifts in Delhi specifically, there are lots of mosquitoes. I'm sure that's a problem in Mumbai as well. They tend to be outside, so we wanted to build something for them that would allow them, now in this case, allow them to kill the mosquitoes, not with their hands necessarily, but more like a James Bond style, kind of moving a watch and kind of uh, electrocuting mosquitoes. So same like the racket that one buys from the market. So we kind of build a wearable version of that here.
Aman, I'm sorry to interrupt, but I think you'll have to wrap it up quickly because we are running short of time.
Yeah, it's just 2 more minutes for me.
All right. Okay.
Yeah, thanks. So all of this work, I wanted to say, happens in a lab that we have specifically designed. The space itself is designed for this kind of research, with the hardware and the open layout and the movable stuff and all that. And it's a quite a nice lab that we are proud of. Welcome people who would like to visit and see how we are doing it here. I'm turning gears towards the teaching side. Worthy is a course. It's an acronym as well as a wearable by itself. So Worthy stands for Wearable Application Research Devices and Interactions. So this is a course that I teach where we do lots of hands-on activities and students explore technology as well as low fidelity materials with their hands. We do not have a full product design program here yet. So this is kind of one of those explorations where students get exposure to materials. And these are the kind of projects that students work on in the course. A variety of projects related to, for policemen, for sports, for servicemen, and other such cool explorations. Okay. This is another course, Prototyping Interactive Systems. This is a first year foundation course. About 500 students were there in the class last year. I had been teaching this course for past 3 years. This is a completely hands-on course, and significant effort goes into a 500 large class and hands-on learning. They just don't go hand in hand. It's one of the unique things that we do here, and quite proud of what we do in terms of exploring kind of technology with your hands from the get-go. I could connect with my experience at IIT Bombay in the first year, where I was in the workshops and learning to work on lathe machines and others. This is quite different. This is more practical, or something that students could connect with in terms of building applications and devices. So that's what we do. Now, onto my last slide. With all these experiences in terms of, and my way of looking at it as a technical HCI researcher, doing kind of different kind of projects in different domains, and then teaching this kind of practices, and mentoring a lot of students. The first thing I want to say, people who may be on the borderline or may
Aman,
have questions about,
we can't see the last slide.
are you on it now?
I can just see prototyping interactive systems.
Is key takeaways visible
Yeah.
now?
Now it's visible. Yeah.
Okay, so this is the last slide. So first thing I want to say, as an academician and as a researcher, and I work with a lot of students who are not necessarily the best in their class. In fact, a couple of students who are at the bottom of the academic pyramid, that your grades or your background does not limit your involvement with HCI. I've seen over the past several years, 10 plus years that I've been involved in HCI, is that people from very, very different diverse backgrounds are in HCI, and they are doing great stuff. And research specifically is not necessarily determined, your research potential is not determined by your grades in your courses. The other thing is, which is more of a personal agenda, is because I get to be reminded a lot that you have to have a very specific research focus. one project that you do for longer. This was something that was kind of tried to made to sink in during PhD, but I still tend to take this approach of it's okay to be a generalist as long as you're having fun, and you can do good HCI research and be excited about it. More on the research side specifically is that to pick your research style is important, whether it's need or curiosity driven. You choose, and it's either one is fine, and you still have a lot of good work to do. Being intentional. So in our case, the space that we designed is very much driving the kind of research that we do. So it's as important as the people and the ideas. And then being hands-on, specifically if you're doing technical HCI research, prototype often and explore new technologies as and when they come. For example, in our case, there is new technology in the market, and if we see potential, we try to get hands onto it. Like Nintendo Switch Labo, we got it quite early, and AR as well as virtual reality headsets. So that helps us kind of understand where the technology trend is going and allows us to then leverage that to come up with new applications and ideas. That's where I stop, and thank you for so much for your time and letting me share my experience with you. I can take questions now.
Thank you, Aman. Is the same process as before? Please put the question in the chat box or raise your hand on Zoom. Sorry. Thank you for the very interesting talk. The projects which you described in the talks are very diverse, both in terms of domain as well as in the terms of digital and physical dimensions. How do you decide what problems to focus on? Do you try to tie multiple projects together?
Thank you for the question. This is definitely something that one has to think about as the research manager for a large group. The question that do I decide? I think as I said, and this is why I said it upfront, is the freedom to choose your path. I falter to the point that I give too much rope to my students that they can hang themselves. I joke about it, and my advisor used to joke about it too for myself. That I let the students kind of propose their own ideas and choose their ideas. The only thing that I try to work with them is about where they are currently in their understanding of the domain, and also helping them see what would you have to do to be able to make a contribution with this particular idea if you want to, right? So I think with that kind of an open, candid conversation, to say that, okay, you will have to understand this space of research. If you're, let's say, going into a new direction that you've never studied, you will have to do this, as well as you will have to potentially develop a proof of concept like this. You will also have to do studies
Hello, Aman. I think we lost you again. Are you there? Yeah,
Hello?
Aman. I think we lost you
Yeah.
again, unfortunately. Yeah.
Yeah, so I was just saying that I let the students choose, and then I work with them to try to understand what do they need to do to succeed in that.
There's one more question that says, thank you, Aman, for pretty exciting work. Do students get a chance to commercially productize these explorations and see if it fits in the real world and make a business model around it?
In fact, they are encouraged to do so, and Tweek is just one of the spin-offs that we have been working on in the past year or so. We are a couple of students are interested in a couple of other ideas that they have worked on as research to commercialize it, and you would possibly hear about more such initiatives soon. So yes, they are encouraged. but they're also again made aware of what would it mean for them to kind of jump in this direction, because the commitment towards commercializing something is quite different from research, at least in the technical HCI research, where it's a quick turnaround, which is a good and a bad thing. It's a quick turnaround there, because at times you have opportunity that is there in moment right now because of a new technology, and it may not be there a year later. So, but that's different than in commercialization, where you got to think about a longer term view of being able to work with your potential stakeholders and understand their requirements to the point that you can serve them. And it's much more iteration and maybe much more frustrating at times, and longer. And just make students aware of that, that what the trade-offs are. And I think they're still excited. A couple of students are still excited to take this path. So we definitely encourage.
Okay. Are there any more questions? I think that's about it. Thank you, Aman.
Thank you so much.
so much. Thank you. It was really interesting, especially as a student. It was very interesting to see it.